Okay, welcome back. So I'm doing some programming in ARM assembly, and the goal here is to write a simple number guessing game. So let's go ahead and get back into it. Let me shrink this down, put that over there. Okay, so at the end of each video, I'm trying to remember to copy the code as it was at the very end of the video. That way I can, upload the code if anybody wants to take a look at it, and they can see like each version as we're going along. So let's go back into our code here. So in part 2, we started the input handling where our prompt is now getting information from the user, but when they type it in, it gets stored as ASCII values of whatever it is that they typed in. So we want to convert the ASCII value into actual integers, and to make life even more difficult, we have to do that one character at a time. We can't just take it all and convert it, unfortunately. So let's set up kind of a handler here. So this actually wouldn't be handling input. This is more like get input, and then this is like handle input. And eventually I want to create some additional files and move some of this handling into a separate file, make it more generic so that, we can use this, so I can use this in other programs. But for now, we'll just kind of prototype all of it right here. Okay, so we got the input from the user, and we're storing in register 3 the first character that was typed in, and then we are subtracting off the immediate value 48, which is just the difference between the ASCII representation of the ASCII representation and the actual value. So for example, if they typed in 0, what we're actually going to get back is the number 48. So we want to take we want to take whatever the ASCII representation of what they type, subtract 48 off of it, so that we always get the actual numeric value. So if they type 0, then 48 minus 48 is 0. If they typed in 1, then 49 minus 48 is 1, and so on. Okay, so we're going to have to loop over this until the thing that they typed is less than 0 or out of range or something like that. So let me think about this for a second. So the last thing we know we're going to see is the last thing is the enter key. And the enter key is a line feed or something like that. Yeah, it's new line, it's 10. So if we subtract 48 from 10, we're going to, if we subtract 48 from 10, we're going to get a negative number. So what we can do, and we know that's always going to be the last thing that gets typed. So we could either look directly for a new line, or we could just say, let's compare the value in register 3 with the immediate value of 0. And if it's less than that, so branch if less than, of course they could also type like a period or something like that, and hit enter. But what we'll say is if it's less than 0, then we think we're done handling, because we think that's the enter key. So in that case, in fact, maybe we don't need to branch at that point. Maybe we just kind of fall through. So let's say up here is the beginning of this handling. So we'll say we've already got a loop. So let's say handle call it handle input for now. We'll make that a label. Oops. And then when we get here, we'll branch back to handle input. But if what they typed was less than 0, then we're done. So branch if less than to, for now, we'll go to the exit for now. Okay, so let me think about this. Okay, let's go ahead and try and save this and run it. And what I expect to see is register 3 constantly getting overwritten with whatever the next whatever the next number is. So let's quit, let's make, and let's bring this up in the debugger. And let's set a breakpoint for 46, the end. Actually, let's look at each one. So let's set the breakpoint at 42, so we can see just before it would branch, we can see what's going on. All right, and let's run our program. So let's try, first of all, let's just go ahead and try a number like 17 for now. And what I expect to see is in register 3, I expect to see 1, and then when it goes around the loop again, I expect to see 7. So register 3 currently has the value of 1. So let's step forward and step. And yeah, register 3 now has the value of 7. And we should step through again. And now register 3 will end up with some, yeah. So it's in sign, in 2's complement, that FFFFDA is like negative 20 or something. Actually, we can see exactly what that number turns out to be. If I copy that and bring it into the hexadecimal changer, we can see it's negative 38, which makes sense because we know the line feed is 10, so 10 minus 48 is negative 38, so it makes perfect sense. Okay, so, and now we should, when we step in here, since register 3 is now negative, we should branch to the exit. And we do, so let's continue through. Okay, so now we are handling individual numbers, individual ones place numbers, but we need to have a total. We need to add these numbers up, and we can't unfortunately just add them together because 17 isn't 1 plus 7, it's 1 times 10 plus 7. And then like if we had 100, for example, it's not 1 plus 0 plus 0, it's 1 times 100 plus 0 times 10, that kind of thing. So once we know that we're not exiting, we need to have like an accumulator, and we can use the MLA instruction, which is multiply and accumulate. So we'll say MLA, and then this one is the syntax, I have to look it up. Where's the developer guide? MLA, okay. So they just have a quick example. I don't like it when they do this. VD, I don't know. Here, this is good enough. So MLA stands for multiply and accumulate. So destination register is equal to RM times RS plus RN. So we need four registers, or at least four values, and it's going to be value 1 is equal to value 2 times value 3 plus value 4. So we'll think of it like that. Value 1 is equal to value 2 times value 3 plus value 4. So let me make a note here, actually. V1 equals, value 1 equals value 2 times value 3 plus value 4. Is that right? Yeah. Okay. So let me think for a second. So we want to take whatever the current number is. Let me think about this for a second. So let's first of all, let's define what the destination register is going to be. So V1, in other words. And we'll do that up here in our initialization section for now. And we'll say that R, well, actually we can just do it right here before we jump into handling the input. We'll say move into R4, the immediate value 0. And that's going to be our accumulator, essentially, where we store the final number. Total. We'll just call that the total. So we want to move into register 4. Whatever value is in register whatever value is currently in register 3 times the immediate value 10, or hang on, I gotta do it like this, times the immediate value 10 plus the new value that we just got. Let me think about that. So let's R3. I might actually just have to look at this in the debugger and start swapping things around until I figure it out. So let's actually try that. Yeah, let's just kind of look at this in the debugger, and then it'll be easier to put things together in my head after I can see what's going on. So let's write this. Let's quit. Let's make. We got an error. ARM register expected. MLA. R4, R3. That's about the most useless thing. Line 45. Maybe you can't have an immediate value here. Sometimes they don't let you do that. So let's say R5. And then we'll move into R5, the immediate value 10, which is just our power of 10 multiplier. Because every time we move over, you know, if you have the number 3 in the ones place, it's 3. But when you move it to the left, it's times 10. So then it becomes 30. When you move it to the left again, it's times 10 again, so it's 300. All right, so does this even make sense? So R4, which is currently 0, will be equal to what we just entered in. Yeah, I feel like there's a glitch here. because I feel like what we're actually saying is that R4 is going to be equal. So if we type in 3, for example, then we're going to end up making it 33. I think that's what's going to happen. But sometimes it's faster for me just to look at it inside, see the numbers moving around so I can follow better what's happening. So let's look at it in the debugger and set a breakpoint for 47 so we can see what the value of register 4 is just before we go back around the loop and run our program. So first of all, let's just try the number 3. So register 3 currently has the value of 3, and register 4 currently has the value of 3. And then when we go back around again, we will exit out. And register 4, which is our total accumulator, still contains the value 3. Okay, so it did not multiply it out to 33 like I thought it might. So let's continue through to the end. Let's run this. Now let's try 15. Actually, to make it a little bit easier on ourselves, 15 is good because that'll translate to the hexadecimal letter F. Okay, so currently register 3 has the 1, and register 4 has 1. And we continue through, or we step forward. Step forward, step forward. So register 3 now has the value 5, which is correct. And now we're going to compare that. And we should not exit. Now we're going to add everything together. And now we have the value 5. So there's still, so that should have been F, not 5. So there's something wrong with the handling there of the way I'm handling that MLA line. So let's continue through to the end. Let's quit. Let's take a look at our code and figure out why I'm so dumb. R4 is equal to R3 times R5. Oh, well, for one problem, I got a typo there. Okay, let's try that again. So now actually what I think will happen is that when I type in 3, we'll end up with 33 as the answer instead of 3. Because I think what I'm actually telling it to do is to take the current number that we just entered in, multiply it by 10, and then add the number again. I think that's what the code is saying, but I just want to see. So let's break at 47 again, and let's run this, and let's again just type the number 3. So register 3 has 3 in it, and now register 4 has 21. And let's convert that, because I can't do that off the top of my head. So let's convert 21 from hex. And yeah, that's exactly what's happening. And that's not, obviously that's not quite what I have in mind. So let's continue through to the end. Let's quit. But at least it's working the way that I thought it was. So now I just need to figure out what's wrong with my thinking here. I think the issue is that, so obviously I don't want to multiply the value that we just entered in by 10. I want to multiply the previous digit by 10. So I need to keep track of the previous digit. So what we could do is each time we load in a byte, so here we load in that byte, so right after we subtract it out, we could say move into register 6 the value, or basically copy 3 over to 6. And then instead of multiplying register 3 by 10, we multiply register 6. That's still not right. All right, I'm going to have to think about this. because what I'm trying to say is we want to keep track of, we want to, if we added in another number, like if it's a 1-digit number, we aren't going to multiply anything by 10. But if it's a 2-digit number, then we're going to multiply the first number we typed by 10, and then take the new number and put that in the ones place. So how are we doing on time? So we're over 20 minutes on this part. So let me just think about this for a few seconds here. I don't want any individual video to be too long, but let me just go ahead and save this as is. And while I'm thinking about it, copy this as vid 3, and then when I come back in part 4, I'll pick it up right here where I left off. I just need to think about this for a second, and then figure out, how that multiplication needs to work. Anyway, thank you for watching, and I'll see you in the next video.